So, welcome to the debugging help session for CS 124. We are recording this help session, so it will be posted on YouTube sometime after today, and you'll be able to go back and review everything that we cover in here. Or if you have friends in the class that can't make it to this, make sure to let them know, and we want everybody to be able to see this help session as much as possible. Yeah?
This is the same one you did the first time?
Yeah, this will be the same help session as what I did before. So we'll be covering the same material and the same techniques. So, for this help session, this is where we're at the point in our class where all of our labs are now going to be straight coding labs. And they're going to be in either assembler or C coding. And with coding, obviously, comes lots of bugs in our program and the need to debug our program and fix any problems that we've got in it. So, Code Composer, the infamous software that we get to use for this class, as problematic as it tends to be, it actually is a quite powerful tool with lots of different features built into it that we are able to use to debug our code and make it so that we spend as little time as possible having to try to find the bugs in our code and fix them. And so for this help session, I'm going to be going over the different techniques that we have for debugging our code and the different tools that Code Composer offers us so that you guys can spend as little time as possible debugging your own code, and we as TAs will no longer have to debug your code for you, because we don't like doing that. We like seeing you guys learn, and it makes a lot less time for you guys being spent on the help queue waiting for a TA to come help you. You can figure out the problems on your own. So, let's go ahead and start talking about some of the tools that we've got. So, Code Composer has built into it. I'm going to go ahead and get us into debugging mode. Code Composer has built into it a number of different tools that we can use. The first one, and the most obvious one, is that green arrow up there, the play button. And that is the button that we use for running our program, as I'm sure you guys have all gotten very familiar with. Well, that play button, it honestly says play from whatever point I'm at in the program. So it doesn't always start at the very beginning. It can start wherever we want it to. We just have to get it there. So we can hit play, and our program will start running. And then we have this handy-dandy little pause button right next to it. It's called suspend, but I like to call it pause because it looks like a pause whenever you're watching a movie or something. And so you can hit pause, and whenever you hit pause, the program will stop at whatever line it's on in its execution, and that line will be highlighted for you. So you'll actually see where your program has gotten to while it was running and whenever you stopped it. So, does anybody know why that might be useful at times? Why would we ever want to pause our program and find out where it's at? Yeah?
I guess if it seems like your program is hung up somewhere, where it pauses will be where it's hung up.
Exactly. If it ever seems like your program is stuck in some infinite loop of some sort and you don't know what's going on, we can use the pause button to find out where it is that our program is halting up on, where it's getting hung up. So that pause button is really, really handy for finding those bugs, because I don't know if you guys have already gotten into problems with like your Morse code or your stoplight labs where they would be running and then all of a sudden it would stop doing anything. You're like, what's going on? And well, the pause button will show you exactly what's going on. So we can pause the program anytime that we want to. And then once it's paused, we can go ahead and tell it to play, and it will continue wherever it was at before. And you can just pause it again, and it happens to be at the same line of code. And you see, it'll just keep running for us, and it'll be at whatever spot it's at. So that's the pause button. The pause button is very nice for finding those problems of the infinite loops getting locked up. Then we've got what we like to call the reset button, which is this black button over here. It's a reset CPU. And what that does is it takes us back to the start of our program. Takes us back to wherever we have reset typed at. And that button is fantastic because it just saves us time. I don't know if you guys have already noticed how annoying it is whenever you're running your program and you have to hit stop and debug again for absolutely no purpose except just to start your program back over. And the debugging takes forever. And just wait until you get into the bigger C problem, the C labs, and it really does take like a minute just to download your program onto the board. It's obnoxious. Well, this reset button is this wonderful button that it says, I don't want to have to debug my code again. I'm just going to reset it from the very beginning. So I just press this button and it brings me back to the beginning, and then I can start it all over again. And I wish that I had known that button whenever I was taking this class. It would have saved me a lot of time. So we have our play button, our pause button, and our reset button. Our two very fun tools that we can use to speed up debugging our code. The next one is a very, very important one, and it's our stepping buttons. So if you look at these arrows right here, your yellow arrows and your green arrows, those arrows are what we call stepping buttons, and they let you literally go line by line through your code to see what your code is doing. So let's say, for instance, you are expecting your code to be doing some really weird stuff. Like, you'll get into some really advanced C problems whenever you're doing your C labs, and your code might get a little hairy at times, and you want to make sure that your code is doing what you expect it to do. Your stepping tools are what let you actually step line by line through your code to see if it's actually doing what you expect it to do. Or sometimes you just want to step it because you've got, like, you're trying to turn on an LED, and the LED doesn't seem to ever be turning on. Well, the stepping tool lets you get to that line and see if it actually turns on when it's supposed to. So we have our yellow stepping tools are what we use whenever we're programming in C, and then our green ones are what we use whenever we're programming in assembler. So, like for Simon this week, you're definitely going to want to use these ones. And you've got step into and step over. Does anybody know the difference between those two? Between step into and step over? Okay, so step into is literally, it's going to go line by line through every single line of your code. Step over is whenever you get to a subroutine. If you don't want to execute the entire subroutine, like go through every single line of it, your step over button is going to go through the entire subroutine for you. So whenever we get to our calls up here in our code, like our call right here, link sub, if we didn't want to actually have to step through the entire subroutine, this step button would let us step over the entire subroutine and it would do it for us. So that's a handy dandy little tidbit there. And it's the same thing with the yellows. The step into will go line by line through your scene code, and your step over will go through an entire subroutine for you. So what do you think we could ever use these stepping tools for whenever we're debugging? How will these stepping tools help us find bugs in our code? When do you think you would ever use something like this? Yeah.
Evaluate specific registers.
Evaluate specific registers? Yeah. So if you're trying to expect certain values to be in your registers, you can step through and see if those values are actually getting put into them. That's an excellent reason. And you'll be able to find hosts of other reasons when you would ever use your stepping tools. Just have fun with them. They're awesome. Now, the most important debugging tool that we have is what we call breakpoints. Has anybody ever heard of a breakpoint in here before? Okay, so what do breakpoints do? What do you understand them to do? Yeah. Yeah, so you put a breakpoint on a line of code. Like here, I'll go ahead and I'll reset this program. And I'm going to pick a random line of code down in here and put a breakpoint on it. to insert a breakpoint, we just double click on the line that we want to put it on, and this little blue circle appears on that line. And then whenever we go and we play our program, our program stops at that line. So we can see that that line is highlighted because whenever we hit that line, the program will stop and it won't execute that line. What do you think we could use this for whenever we're debugging our code? What would be the power of being able to put a stopping point on a line and making sure that the program stops whenever it hits that line? Yeah. Test specific areas of the code. In what sense?
Subroutines.
It's like subroutines. So test to see if we actually get into a subroutine, or like we could put a breakpoint at the start of the subroutine and then at the end. So we wait to see if the code ever, once it gets into that subroutine, then we could step through the entire subroutine or play through it and see if it gets to the end of the subroutine and see what happens. So that's a very good reason, a very good way to use it. Some other things that we can do with breakpoints are if we are expecting our code to get to our program to get to a certain line of code, we can put a breakpoint on that line to see if it ever actually hits that line. For instance, whenever we want LEDs to turn on or whenever we want sound to be output, we can put breakpoints at the spots where the LEDs turn on and see if it ever reaches that line. And then if it does, we'll expect the LED to turn on. But if our LED isn't turning on, it might not be reaching there. So then we can use our breakpoints to put spots further up the code and see where our code is getting to and see where it's breaking. So this essentially will be expecting it to get somewhere, and then the breakpoints will tell us if it's actually getting there or not. Another really handy use of breakpoints is if we get ourselves caught in a loop, like we've got a loop right here on our blink subroutine down in here. Well, if you start stepping through it, this loop is going to go on and on for, hundreds or thousands of times. Well, nobody wants to sit here all day just stepping through a loop like that. So what we can do is we can put a breakpoint at the end of the loop, and then we can just hit play, and then it gets to that point. And then we can take the breakpoint out, and then we can just continue stepping through. So that's one way that breakpoints are very handy, is if you're stepping through your code and you need to get to the end of a loop, you don't want to have to step through the entire thing, so you put a breakpoint at the end of the loop, and then you just continue stepping through. And so that's one of the many, many uses of breakpoints. And there's many more out there that you'll be able to find as you'll be debugging your own code. So now, the last little feature that we have built into Code Composer is out here, we can check the values of our registers. You can see that we've got all of our different registers here, and we've also got all of our different ports here. A little further down. Port 1. There we go. So this is very handy because at times we can check our registers to see if they actually hold the values that we expect them to hold. Because sometimes we'll expect them to hold a number like 10 in a register, and you'll go up and you'll check the register value and it has like 25,000 in it. And well, that's obvious sign that something's going wrong with our code. It's not doing what we expected it to do. So we can check the values of our registers and know whether or not our code is breaking in that way as well. And so those are the different tools that we have for debugging our code that Code Composer offers us. We have our play button, our pause button, our stepping buttons, our reset, breakpoints, and we have our register values. And those are the different features that we have at our disposal for being able to debug our code. And I promise you that if you use these, it will save you a whole lot of grief whenever you are trying to debug your code, as opposed to waiting on a TA to come do it for you. One reason, because if you use these and you still can't find your bugs, if you can show the TAs that you have been using them, they're going to be a lot more friendly with you than if you just say, find my bugs for me. Whenever a TA walks up and a student is like, okay, I've been debugging my code, I put breakpoints in here, I've tried stepping through it, I've checked my register values, and I can't find out what's going on, the TA is going to be like, oh, you're actually trying to fix your code for you. We'll love to help you now. Whereas if you just put yourself on the queue and the TA walks up and you're like, so, it's not working. The TA will be like, okay, what have you done? And you'll be like, I've just sort of stared at it, and they'll be like, well, keep staring while I go help somebody else. So, if you try to debug your code, most likely you'll be able to find the bugs yourself, and if you can't, a TA is going to help you a lot more and a lot faster. So, with all that said, those are the different techniques that we've got. So now what we're going to do for the remainder of the session is I've got a simple Blinky program that I have built, and that I've got a copy of it that is a functioning copy, and I've got a bugged up copy. And I'm going to show you the functioning copy, and then we are going to try to fix the bugged up copy. So, first off, this is the functioning copy. I'm going to go ahead and reset the program. I'm going to play it for us. Nope, that's the bugged up one, never mind. Oh, I do. What do you know? Okay. No, I think it was a breakpoint. Okay. Okay. So the video probably isn't going to be able to catch this, but it's a very simple Blinky program. All that it is just a simple pattern of blinking the red light on, then both on, and blinking the green light on, and then blinking both on again, and then just repeats. So it's a simple Blinky program similar to some of the other labs that we've already written, and we are now going to fix a bugged up copy of it. So I'm going to go ahead and stop this. And now we'll go ahead and debug this. And now we get to have fun. Okay, so here we go. We're going to go ahead and play. And we can see that all that is happening is the red LED is just staying on. So now we get to find out what is going on with the code. So, let's go ahead and take a look at the code. What's the first thing that we should do if we see that our code is getting hung up in something like that? What's one of our tools that we should do? What did we decide we should use whenever we're hung up in an infinite loop? Yeah. Yeah. We're going to pause the program and see where it's getting stuck in. So let's go ahead. Oh, that was interesting. We'll pause it, and we can see that we're at the reset. So one point that I'm going to make right now is the reason that your code resets on you is because it's crashing somewhere. Most of the time, the reason that it's going to be crashing is because of a subroutine where you're making a bad call, or you are pushing and popping in the wrong place, and it's causing your stack to be broken. So most of the time, if your code is ever resetting on you, at least 90 or 95% of the time, it's going to be because your subroutines are messed up in some sense with the stack. So we see that our program is resetting on us, so it's probably got something to do with the stack or a subroutine. So let's go ahead and just start stepping through the program. So we'll step through. That's all of our reset stuff. So now we come to a bit set. On P1 out, we're going to turn the red LED on, so we can check step to see if that happens. And we see that the red LED turned on. And now we're going to make a system call, and we're going to call down to our blink subroutine. And we did not go there. What does that tell us? If we see ourselves making a system call to a subroutine, and we reset instead. Sorry?
Is there a label for the blank sub?
Let's check that. Let's see if we actually have a subroutine called blank sub. I'm going to expand this a little. And we can see down here that there is a subroutine called blank sub. We see that we've got a return down in there, so it is a subroutine. So we do have a valid subroutine called blank sub. That's a good question. So how do we make a subroutine call? We want to use the call keyword, and then we give it the name of the subroutine, but is there anything else that we need? Pound sign, the hashtag. So here's something that is really, really, really important to note, because I can promise you at least 90 to 95% of the students make problems with these different symbols, and most of the time it's confusing calls and jumps. Whenever we're doing a jump, you don't use a hashtag, and whenever you're doing a subroutine call, you use a hashtag. Those are two very easy things to mix up, and so just always remember, whenever you're doing a call, you use a pound sign. So we've got a call right here. We'll go ahead and put pound sign in there. Now, since we changed our code, we're going to have to debug it again. So let's go ahead and debug that. Alright, and now we'll go ahead and play and see what happens. And we see that the red LED continues to just stay on. So we'll go ahead and pause the program again. And we see that we got down into our subroutine. So that's a plus. We actually made the call and we got down into here. So now that we're down in here, might as well just start stepping through it. So that's what we're going to do. We can start stepping. And we see that we've got ourselves a loop right here. And what we would like to do now at this time is go and check our registers to make sure that our values look normal. So we're going to open up our core registers. We'll come down in. R15 has some incredibly high value inside of it, 63,000. That doesn't look right. You see that we moved into R15 a blink value. So let's go ahead and go up to our EQUs. Let me check. Blink is a 0. Okay. So we start things off at 0, and then we're going to count down. Well, in that case, this value does actually look like it makes sense. Because whenever you start with 0 and you start decrementing, you go to -1 and then -2, and then you wrap all the way around. So that's actually a pretty valid number for it. So we'll go ahead and we would keep stepping, but we can tell that this is going to take forever. So what do you do when we get to a loop? It's going to take forever to go through. We put a breakpoint at the end of it. Then we'll go ahead and play it through, and it gets down, and we see that R15 got down to 0 successfully. So now we'll go ahead and take our breakpoint out, and we'll continue stepping. Step, and now we've reached the end of the subroutine. We would expect it to go back to where our call was. So let's see what happens, and we see that we reset. So if we reset, what does that mean? There's a problem with the return. So let's go back to that return and see if we can find where the problem is. So the return looks right, but does anything around it? Oh, does anything around it look fishy? Yeah. So we did push to make our subroutine callie save, which is what we want, and then at the end we're supposed to pop, but we're pushing instead. So that is definitely going to cause us much grief. So let's go ahead and fix that. Now we'll go ahead and recompile. And now that we fixed a bug, we'll go ahead and play and see what happens again. And we see that we've still just got a red light on, is all that we've got. So we'll go ahead and pause once again. And we see that we're getting down into our subroutine. So we'll go ahead, come on up and step through. We're in a loop, so we put ourselves a breakpoint at the end. We play it, get to the breakpoint, take the breakpoint out. Oh, and to remove breakpoints, you just double click on them the same way that you put them in. I guess I should mention that. So then we'll go ahead and we got to the return, and we see that we returned. So now we've got a bit clear on our LED, so we expect the LED to turn off, so we can go ahead and step it. And we see that the LED actually did turn off. So that's a good sign, though it's a weird sign because whenever we play our program, the LED is constantly on. Yet whenever we step through it, we see that it goes off. This is something that probably some of you have seen in some of your previous labs. And it's something that happens very often. So let's find out where it's breaking on us. So we can go ahead and step through. We're going to hit and define some delay constants. And then we're going to get ourselves into a loop right here. So that's fine. We'll go ahead and put a breakpoint at the end of that loop. Play it through. See that it gets down to 0. We can check that in our registers up here. See that R14 did in fact get down to 0. We'll go ahead and reinitialize our R14. And then we'll decrement our R15. Ooh. Okay, we can see that we're going through this. So that's a loop. We'll go ahead and put ourselves a breakpoint at the end of the loop. And then we'll go ahead and play it. Oh, there's a breakpoint right there. So we'll play it. Oh, so we do see that we get down to this line, turn both the LEDs on. That's what this command right here is doing, is turning both LEDs on. So we'll go ahead and step that line. And we see that, in fact, both LEDs do turn on. So somehow our code is getting to the point of turning both LEDs on, yet we never see that whenever it's playing. Very fishy. And I think that he just caught it if we are about to make our subroutine call, and we step, and we reset. And like this man in the front said, we'd need a hashtag. We forgot our hashtag once again on this line right here. So we'll go ahead and put a hashtag in, stop our program, save it, recompile it. Now let's see what we can find. So now if we play our program, ooh, breakpoint, good. Take that out. We'll reset it and watch it from the beginning again. Well, that's interesting. Now both LEDs are flashing at us. Wonder why that would happen. So we see ourselves in an infinite loop once again, so we'll go ahead and pause our program and see where we're at. Well, we're back at where the red LED turns on. That's interesting. So we got to the point where both of our LEDs turned on, but the red LED is where we're at. And we know that we've been able to make it to this call point right here. So go ahead and put a breakpoint in there and play it until we hit that line. So now we've gotten to where we know our program works. And now we're going to go ahead. We know that our blink subroutine works, so we're going to go ahead and assembly step over it to the next line. So now we see that we've got both LEDs on, and we're going to go ahead and see if both of them turn off whenever we do a bit clear. And in fact they do. So you can see that both LEDs have turned off. And now we're inside of here. Now let's find out what's going on. We set our R14 and our R15 values just like we expected. And then we're going to go ahead and get ourselves into a loop right here. That loop is going to take forever. We'll put a breakpoint in, run through it. Now we'll go ahead and step, and step. Uh-oh. And where did we step to? We stepped to the wrong loop. We went back to red, our red LED turning on, which is not what we wanted. So we'll come down here. This is our line where we broke, and we can see that we're going to inner loop 1 instead of inner loop 2. So we want to go back to inner loop 2 and reset ourselves. So change that. We'll run through it. Now we'll go ahead and run our code, hit a breakpoint, take that breakpoint out, play it, get to this breakpoint, take it out, and now we'll go ahead and reset and watch what happens with our code. We can watch it and uh-oh. So one turned on, both turned on, and then it stopped. So let's go ahead and pause. And we see that we're still in our inner loop 2. Well, let's see here. We can go through this loop. Let's go ahead and check our registers, see what's going on up here. You see that R14 has a value of 5,713. Well, if we go to where we initially set R14, delay 1 has a value of 200. Yet R14 has a value of over 5,000. That doesn't quite sound like what we would expect. How did it get above what we initialized it to if we're just decrementing it? Sorry? So, if we think about it, we'll go ahead and put a breakpoint here. And we run, and we get down to here. So now we've got a value of 0, as we can see, up in R14. Now if we, that's not good. So we've got a value of 0 up in R14. Now we step, we decrement our R15, and we jump back up, and we're going to start decrementing R14. So we see that the value skyrocketed. That's because we forgot to reinitialize our value of R14. We're jumping to the right label. It's just that we need to remember to reinitialize our value in R14 before we start changing it again. So what we would want to do is down in here, we would say move.word pound delay 1 to R14. This is a value, this is a bug that students and TAs and professors make all the time. Is you're in a loop that's nested inside of another one. You go through the inner loop and you forget to reinitialize your value in the inner loop before you do the outer loop, because we're so used to programming in Java or C++, and our loops just reinitialize our stuff for us. So in assembly, we have to do all of that initialization for it. So now we would expect it to get further in our code. So we go ahead and play. I don't know what happened. I don't know. Something happened. And this is where Code Composer is really annoying. There we go. Okay, now we'll go ahead and play our program. And we see that it is still breaking on us. So, we pause it. Well, we see that we got down to inner loop 3. See that we got down to the point where we would expect the green LED to come on. Yet it never actually came on. We can watch it again. Reset. and we play, and let's see if the green LED actually does come on. So we'll go ahead and put a breakpoint at the point. So this is the line where we would expect our green LED to come on. So let's play. We break at that line, so it should theoretically be coming on right now. Let's step it and see what happens. We see that it didn't actually come on. Well, that's a huge problem. So what is the problem with this line right here? Yes. There's a huge difference between P1 dir and P1 out. Or lout, too. You can see that we made that same mistake down here. So let's change this to P1 out. We want to remember there's a difference between dir and out. Dir is setting our LED as output versus input, and then out is actually turning the LED on or off. So we want to always make sure that we're using P1 out whenever we're supposed to, and P1 dir whenever we're supposed to. So now, yes, we need the ampersand sign as well. That's a very good catch. Where? Right here? It really doesn't make a difference if it's inside or outside. I am? No, I'm always jumping back to inner loop. That should be fine. We could put this move inside of here. The only difference that it would make is that we would be reinitializing it every single time we get in here, which honestly, that would work just fine. So, we'll go ahead and run our code. Oh, sorry. Let's go ahead and run it. Oh, there's a breakpoint down in there. We'll reset. And we'll run. Okay, so we see that, well, let's see that again. That's kind of fast. So we got the red LED to turn on, both green LED, and then it stops. So we're getting hung up somewhere, so we'll go ahead and pause the program, see where we're at. And we see that we're in our green LED loop. So let's find out what's happening. We'll go ahead and step through it. Ooh, that looks problematic. Let's check our values in our registers. We'll go ahead and step. And we see that we are decrementing our R14. No, not R14. Okay. So we see that R14 is decrementing like we expect it to. We'll go ahead and put a breakpoint. Play it to that point. R14 got down to 0 like we expected. We'll go ahead and reinitialize R14, decrement R15, and then jump back up. And we see that we are resetting the value of R15 every single time that we go through our inner loop. Well, our outer loop is never going to end if our inner loop keeps resetting it. So that tells us that we need to move our label from here down to here. That's one problem that we see happen with students a lot, is they'll be reinitializing their variables inside of their loops. That's a huge, huge problem. So always make sure that you're reinitializing your variables in the right spots so that it's not going to give you an infinite loop like what we just had. So now, we'll go ahead and we see that we've got a breakpoint. We'll take the breakpoint out, reset, and now let's go ahead and watch it and see what happens. That's interesting. You see that we're turning one on then both of them on, then the green one, and then it's starting over. Seems like we're resetting again. Let's go ahead and pause. And let's put a breakpoint at the spot that we know we can get to, which is, we believe that we can get to the end of this loop right here. So we'll reset, and we'll play and see if we actually hit that point, and we see that we do. We are getting to that spot, and we'll go ahead and step. Okay, we got ourselves caught in a loop. So, we know that we can reach this point. Let's see if we can reach the next line. Go ahead and play. Okay, we reached that line, so that's a good sign. So now we're going to go ahead and see if our LEDs turn on like we expect them to. We see that both LEDs are turning on, which is a very good sign. And now let's step again, and we reset. And what does a reset flag us as happening? What does that tell us? It tells us that we've got a problem with one of our calls or one of our push or pops. And if we come down here, we do in fact have a missing hashtag. So put the pound sign in. Go ahead and stop. We'll save. And then we'll go ahead and try debugging again. And then we'll go ahead and run it, see what happens. We see that we got to our breakpoint. That's good. We'll go ahead and reset it and watch it again. And if we watch, well, we see that we got the pattern to go, but it stopped on us. It's probably we've got an infinite loop somewhere. We'll pause and we'll find out. We're getting down into this loop. Let's see if we can find ourselves an infinite loop real quick in the last few minutes. So we got ourselves a loop right there. We can check the values of our registers. We see that R14 is really high, higher than we would expect. So that's a red flag. Something's going wrong. Let's see if we can find it. Put a breakpoint after, play it through. We get to the end, R14 gets down to 0. Let's step see what happens. So we are reinitializing the value of R15. And we didn't reinitialize the value of R14, because R14 now is an excruciatingly high number, which we can play through, let it get down to 0. And this is where we would normally reinitialize it, but instead we're reinitializing R15. By watching those values of those registers, we can tell that our problem is on this line right here. We'll reinitialize R14 there. We'll stop. We'll reset. Debug it. And now, if we watch, we might have a breakpoint in there. Yep, we do. We'll take the breakpoint out. We'll reset. And there we go. And we've got our pattern going. And so, I don't know if you guys counted, there was something like over 10 bugs in that program, and we managed to find all 10 of them in like half an hour. So imagine putting that to your programs where you've got maybe 2 or 3 bugs in your program, and instead of having to spend 4 or 5 hours debugging them, you could get it in 20 minutes. So that's the power of being able to use these debugging tools in your code whenever you're writing your own programs. Because, I mean, look, we saved ourselves a ton of time. So, that is our debugging help session.